Hi everyone, this is Arunachalam, and now we are going to see about my overall MCA major project which I have done in Weltec High Tech Engineering College, and my project title is Brain Tumor Segmentation using Deep Learning Framework, and I'm guided by Senthil Murugan, a PhD, and co-guide Manikandan, and this is company details and abstract. Initial days they by using manual segmentations of the brain tumor for cancer diagnosis from MRI images is difficult and it take a lot of time to diagnosis. And the accuracy and the robustness of the brain tumor segmentation, therefore the crucial, they are most important for the diagnosis, treatment planning, and the treatment outcome evaluations. Mostly the automatic brain tumor segmentation methods we have used in hand designed futures. And so now we are describing a new model which will overcome that every week. And now we are come with a new model, a two pathway group CNN architecture for brain tumor segmentation, which exploits local futures and global conceptual futures simultaneously. This model enforces occurrence in the two pathway CNN. CNN means a convolutional neural network which we use for the machine learning instructions which we can give it, and it's a famous algorithm which we use to train the what waves to the machine. And this is the introductions. If someone have a brain tumor, means that they themselves have as a unnatural and uncontrolled growth and divisions of cells in the brain. Healthy brains consist of three types of tissues, or gray matter, white matter, and cerebrospinal fluid. And detection and segmentations of cancerous cells used with before this they're using the MRI images, and now MRI images not only helps to detect the presence of tumors and their location, but it also enables the identifications of tumor size. Existing systems before what they used in to diagnose the brain tumor. In construct and automatic brain tumor segmentation methods use hand designed futures, and before this they were using hand designed futures and a variety of images, futures intensity and texture. In that they will extract the image and they will find out the brain tumor. And for they were used most commonly adopted classifiers to classify the every images. The most used is support vector missions SVM and random forest neural networks and genetic algorithms. And in that they want to get up pure informations and segmentations of brain tumors. They will get the tumor which a human have or not. Whereas discriminative models depends on a set of features and classifiers. Problem statements, as we said in the existence, we want get a priori informations in the generative models, which are the MRI images models, which are extract and different type, differently angled in that, and segmentations of brain tumors. It's a mostly to a time consuming task. It will take great time to diagnose the cancer, and this is a way as you guys just pass and go through that and propose a system in this to overcome every problems which we saw in that time consumed. I take time or a lot of times to find out the brain tumor. Now we are in a proposed system, so we have introduced that two pathway group CNN architectures. CNN is as I said, it's a convolutional neural network which is an algorithm to train the machine which what actually we want to get output. And for brain tumor segmentations which exploits local futures and global conceptual futures. Local means in local means it will extract the futures in inside and outside every part of the images which patients have. And the model enforces equivalence in the two pathway CNN model to reduce instabilities and overfitting parameter sharing. Finally, we import the cascade architecture into a two pathway group CNN, in which in the output of the basic CNN is treated as additional sources and concatenated at the last layer CNN into a two pathway architecture. Improve the overall performance over the currently published state of the art, while conceptual complexity remains attractive in this. And this is a architecture diagram which I have done. The input hatch going through two pathways of convolutional networks. It will see that MRI, the images is there, and which we could put it in the data set, and it will extract with that two path convolutional neural network, and it will extract the global and conceptual features in that, and at last every local and global paths which we show in that, and in that only it will diagnose, it will extract, and it will diagnose with every angle it will extract that. So finally we get an actual output in this. And collaborative diagram, which user input, we input the images in our data set, and image pre-processing is used to convert the raw data. If you're collecting data image, it will put as a raw data, and it will convert into a clean set data. For that you are using image pre-processing. And image segmentations is it we used to segment the images in different angles, and two-path conversion which you used to train the algorithms and parameter setting, everything it will be done in that. And the feature selections, the concepts and the global concepts of features which we done in that, and video it will give the features of every angles we are in a different side of the images. And finally we can give the output with our tumor detections the humans having or not. The actually diagram, image pre-processing, image simulations, actually what you have said in collaborative diagram. This is you all go through this, and the model descriptions which we are model I done this project with the first move for this data set. Data set. Oh yeah. Data set, data pre-processing, parameter setting, training, and evaluation parameters. Now we are going to see describe about this models data set the augmentations of performance of deep learning neural networks often improves the amount of data available, and the data augmentations is a technique to artificially creates new training data from existing training data. This is not actual thing. Okay. Data pre-processing is a technique that is used to convert raw data into a clean data set. Whenever the data is gathered from different sources, it is collected in raw format, which is not flexible for analyze the actual thing. And so only we go using the data pre-processing and parameter settings. It is a different aspects of analyzing images into automatic and pathologically meaningful of reasons. Pre-specific values of the edge, E, grays values of G, and local constructs. Model 1 output which has data set, and we are data augmented and a different set, and then it will extract everything. This was my finals. Thank you everyone.